So can you give it a read? I want you to, this is what you're gonna have to deal with, guys. You ready? You're gonna be a bit overwhelmed and bombarded with information. You're gonna be like, oh my goodness, there's all of this going on. You need to be comfortable with first reading, kind of imagine the scenario, and then do one thing at a time, because the often is going to be like, what is the cost going to be to do this reno? You can't do it all at the same time. You got to do one at a time. Okay. Another thing I want you to really think about is, does this thing involve surface area? Does this involve volume? What are we talking about? Because some of you are mixing up formulas for volume and surface area. You don't want to mix that up, okay? And things like that. So for now, please read it. Don't solve anything yet. Just read it and maybe highlight some things, maybe mark, circle some things that are kind of standing out. Pretend like this is an exam question right now. You're sitting there and you see this for the very first time, okay? So I'm going to ask you to read it. I'll do the attendance, and then we'll take it. I'll take it from there. I actually made this thing as a 3D iPad. I used the iPad with Tinkercad. So we're actually going to take this thing and turn it on its side and top, bottom, whatever. We're going to move that around. Okay. Read it. Don't do anything else but read it right. You ready? Okay. Here we go. So Ms. Yosik is building this fish pond right at the center. Let's have some highlighters go on here. Use highlighters. They're really good. They make it a bit more manageable.
Excuse the attention, Jake Lavalley to Route 51, please. Jake Lavalley to Route 51.
So we've got the pond. We've got a donut shape around it. That's the garden. And this is the design, so we know that's 12 feet here. This is 2, 6. You got to watch out, the 2 and the 6. They'll probably have to be used in combination. Let's see what it's asking us for. Okay? The pond will be in the shape of a hemisphere. The pond is a hemisphere. Do you understand that, right? So it's going to be, it goes in, right? It digs in, and the bottom of this pond, right, is a hemisphere. Think of it that way. With a plastic liner that must be installed. The pond must be excavated before the liner is placed. So this has to do with the center, right? The garden will not be excavated, but it's 4 inches deep with topsoil that will be added. Okay? Excavate means like digging it out. Yeah, that's probably good. Excavation is you're digging it up, okay? So there's a bit of a depth to it, okay? So let's see here. Pond liner and water pump cost $150 altogether. Watch, like that's actually just saying this is what that costs. There's no square footage, there's no cubic, nothing, okay? The soil is sold in bags that contain 2 cubic feet of soil, okay? So we're going to highlight that. Right, the soil is sold in bags and it has a volume to it, and each bag costs $6.99. Excavation is $125 per cubic yard. Excavation, I'm going to highlight the whole thing. That's what it costs to dig out soil, okay? This one, I think everybody understands that you have to buy 2 cubic feet at a time, okay? Because it's a bag. You can't buy partial. This one is not so clear, but the implication is that, okay, all items must be purchased in whole units. So what that means is that we have to pay for a cubic yard at a time. So if somebody digs out a cubic yard and digs out just a little bit more, you're going to have to pay $250, right? Because you're going to have to pay for 2 cubic yards. So whole units only, keep that in mind, okay? All right, A, determine the cost to excavate the pond, not including taxes, okay? I think I could probably manage to get that in here. So I'm going to do that just right here. Or should I? Yeah, I think I can make that work. This is A right here. The volume of the hemisphere, because we know that the pond is a hemisphere. What's the formula? 2 pi r cubed divided by 3. That's what I would start with, right? Because excavation, how do you know it's cubic? Because excavation is in cubic units, right? So keep that in mind. So let's figure out the volume here. 2 pi radius. What's the radius of the pond? The radius is 3, right? It's going to be a bit busy here, but I'm just going to say that this is 3. Okay, from the radius of the pond is 3. If I use 3, guys, what is the unit for this? The 3 is in feet, correct? You notice that? So what's my volume going to be in? Cubic feet, okay? What is it sold in, or what do they charge me in? Cubic yards. So you got to watch out for that. But let's just do this first, okay? So let's figure out what that is. You should probably follow with your calculator. I'll do the top first. So 2 pi, 3, close it, hat 3, divided by 3. That's 56.54 something cubic feet. I'm going to convert that. The volume is 56.54 something cubic feet. What's the conversion rate? I know that 1 cubic yard has, do you have that on your study sheet? I gave you this, right? 1 cubic yard has 27. You have that, right? Yeah. Okay, I'm pretty sure I gave that to you. And there we go. So we're going to go divide it by 27 in a sense, right? We divide by 27. That's 2.09 something cubic yards. I think it was a bad call to make that, to fit that in there. Sorry. So now we know exactly what it will be to excavate, right? 2.09 and then some cubic yards. So now we're going to do the cost though. So we will go, would it make sense to you that we need approximately 3 cubic yards? Because we can't buy 2.09. We need to do this. So cost will be 3 times 125. There you go. There you have your cost. And you might wonder, but we didn't divide by anything, Mr. Dirksen. You know how the square, when we did painting, we would go, oh, a can covers 200. Let's figure out. In this case, you don't need to, because whatever cubic yard you get, you just round it and then multiply it by your, it's almost like one big excavation is 1 cubic yard at a time. So if you were to divide this by 1, you get 2.09. You've got to round it to 3. Okay, so there you go. That's not including taxes. So we're going to leave that. So that's A. Okay, all of this is just part A. Probably 3 marks probably in here. Volume gets you 1, converting gets you another 1, cost gets you another 1. 3 marks in that section. Okay. I did add quite a few layers to this question. So B, what is B asking for? Determine the cost of soil to build the garden, not including taxes. So we don't want taxes yet. Now I need to zoom out a little bit. I think I will do. Can you see there? I want you to see the diagram, but I also want you to see the work. Okay, here's where I'm going to use my iPad, and hopefully this helps too. This is the scenario. Again, okay, so this is the top view, right? We've got our pond in the middle, we've got a garden around. So if you were to go sideways, that is what you would see, okay? So you've got your hemisphere pond in the middle, right? And then you've got this garden around. That donut, right, is a garden around. It has a depth to it, right? It's 4 inches deep because we're putting soil on top. So you're kind of building it up a little bit. Okay, so you're thinking volume, hopefully. Do we have a formula for that garden, for that shape? Yeah. It looks like a cylinder, right? But we don't have one that just takes care of that orange part, right? So what would we do? Let me see if I can do this for you here. Watch this. How would we find the volume of that? Like, let's take the pond away. How would you find the orange? Volume of large cylinder minus volume of small cylinder? That's what you would have to do there. Because you don't want that center. Okay? So here we go. I wish I could like copy and just throw one in your sheet right now, right? So what I'm going to do here is I'm going to do a side view. And this is where your artistic side will help you out. I don't have that, okay? Sorry, I apologize. This is as good as I can. So to get that, we're going to go to get the volume of the garden. We're going to go volume of large minus volume of small. Okay, this is the small cylinder in there. And I know some of you might be thinking, but Mr. Dixon, there's a hemisphere in there. Like, what's going on, right? Think of this circle. Think of this circle is like the top of the pond, and we sprinkled some soil around it to build it up, right? So that's why we're considering a cylinder that we're going to be taking away. Okay, so here we go. This is B right here. Volume of garden, one more time. It's going to be volume of large cylinder minus volume of small cylinder. Let's do the large one right here. What's the diameter of the large one from end to end? It's 6, right? Please don't forget, a lot of you go 6 plus 2 is 8, Mr. Erickson. Obviously it's 8, but don't forget about the 2 on this side, right? If there's something all around. So this is 2 plus 6, that's 10, correct? So let's call capital R 5, capital radius of the big cylinder. And then we'll do small cylinder. This is 6, so that's lowercase r is 3. Okay, so these are the two bases of our two cylinders. Does the height matter, like the depth of it? Do they have different depths? They're both the same. Okay, they're both the same. What is the depth of it? For what? Inches. How do we turn this into feet? Because everything is in feet. What do you do to anything in inches? Over 12. Yeah. So same here. It has a bit of a depth. This is 4 over 12 inches. 4 over 12 feet. As soon as you go over 12, it's now in feet. Okay? So here we go. Pi r squared h minus pi r squared h. This one is 5 squared. Yes, this is annoying. 4 over 12 is annoying, but you've got awesome calculators that help you with that. So type this in and see what you get. I would use brackets exactly the way I've been using them. Okay, so pi 5 squared, 4 divided by 12. That's 1/3, I know that. 1/3. If you want to use 1/3 instead of 4/12, that's fine. You know what? It's probably good. Oh man, I erased the whole thing. Oh, yeah. I will hit enter here to get the first part. 26,179 something minus. I will just copy paste that work and change my radius to 3. That's 9.24, sorry, 9.424 something. That's 16.755. Don't be too eager to round. This is in cubic feet. So that's how much soil we need, correct? Exactly how much we need. Now you're going to go to the store, and how are you going to figure out how much to buy? Divided by how much does a bag contain? 2, right? So it's 16.755 something divided by 2. I'm going to look that's 8.37. How many do I need to go buy? 9. But really, in real life, how many are you really going to buy? I would say buy 10 and return if you don't use it all, right? That's a complete aside. That's just me, okay? Because what if you messed up on your measurements? Right? The worst thing is to almost be done with your project and having to go back, right? Okay, cost is 9 times, what are the bags costing us? $6.99. And we don't care about taxes here, so we're just going to go 9 times 6.99. That's $62.91. I'm just going to circle that, put a $sign around it, and you're done that part. Okay? C. The pond liner, the water pump, and soil. Watch this here. Pond liner, water pump, and soil have both GST, PST. But watch this, but the excavation only has GST. What's GST again? We have it right there. 5%. Why is excavation only 5%? It's a service, yeah. You can't say like, give me some excavation, please, right? You can't. Like, they can just excavate for you. It's a service, okay? So total is going to be like this, and everybody does it differently. I don't care how you do this, but I'll do this. The liner and pump is 150. 150 for liner and pump, 62.91 for the soil. And this I'm going to multiply by 1.12. Plus the excavation is 375. I'm just going to multiply that by 1.05, and I'm going to put that in brackets like that. And let me see here. I thought I had it all ready to go. Concrete. Some reason I can't find it, so I have to calculate it the old school way. If I add this, you get 212.91. I add taxes to it. That's 238.46 plus this part right here, 375 times 1.05. That's 393.75. $632.21 is the cost to do all of this work. And I think D, we will have the back side of this, I believe, to do that one. So for D, we are going to go to the next page. But let's read before we go. Ms. Yosik would also like to build a walkway from the house to the garden that is 3 feet wide. It is to be paved with bricks that measures 4 inches by 8 inches. Indicate the total number of bricks required for your design. Let's go up to our diagram here for a bit. So you're going to make a walkway like this, connecting the house and the pond, right, and the garden. And we know this is 12 feet from end to end, and we know that it is 3 feet this way. Are you thinking, what are you thinking? I'm curious, because are you thinking area or volume when you're putting bricks down? You're putting it on top. It's area. And you're covering a surface with blocks. So that's the first clue that it's area. The second clue, there's no depth mentioned, is there? There's no depth. Like we couldn't even find the volume even if we had wanted to. Okay? So no, you can't. So let's go to the back side of this. So for D, what I'm going to do is I'm going to figure out the area. This is 3 by 12. This is in feet. This is the walkway. Okay? And this is a brick. A brick would be what? How much does one brick measure? 4 by 8. But what is it in? It's in inches. Okay? So we want to know how many of these do we need to pave this thing. Okay? We're going to put pavers in, we're going to put blocks in there and cover up that space. If you're ever going to make a patio, this is exactly the math that you're going to want to do. You measure the space that you want to cover with rocks, and then you do the math, and then you go and buy them, right? And always buy extras because you might be off, by the way. So what I'm going to do is I want to find out the bricks. I want to find out how many bricks. So I'm going to go area of walkway divided by area of a brick. This is like number of cans. I will take the area, total area, divided by the area that one can covers. That's how I find it. So how about this? Area here is what? 3 times 12 is 36 square feet, correct? What's the area of a brick? 4 times 8. That is 32 squared inches. We can't just divide them as is, right? Different units. But we know that 1 square foot has how many squared inches? 12. 12 squared, 144. Cancel, cancel. 32 divided by 144, it's going to be a weird number. So you go 32 divided by 144, 0.22 something square feet. And that's because a block that is 4 by 8 is like this big, right? It's just literally this big. So how many of those can you fit into a big space, right? So we're going to go 36 divided by 0.222, don't round, okay? 36 divided by that, oh, it's an exact number. Look at that. If it hadn't been an exact number, you would want it round to a whole number. But that's how many bricks you will need to buy when you make this walkway. Okay? A couple summers ago, I made a patio that looks like this. Right? So you walk here, and then there's like a circle meeting a rectangle. And so I had to do the math. I had to find the diameter of this, right? Pi r squared. And then you have a rectangle here. You find the area of that. You combine them. You divide it by, most bricks are, 4 by 8 is a very standard brick size. 4 by 8. There are squares like 12 by 12, like bigger pavers, right? We call them pavers. Or there's the concrete blocks that are 24 by 24, so they come in different sizes, right? So then you just decide what pattern do you want to go with, and then you go, right? So for example, let's say I go shopping. I'll make sure I know this number, 36, and then I go and I look at the design that I like, and then I'll be like, well, what's the area of just one of those blocks, right? That's where this comes in. And then you divide it by 144, and you want to know how many square feet does that block that I really like, how much does one of them take up? You'll multiply, it's most likely going to be in inches. You multiply the dimensions, then you divide it by 144. It's always going to be 144. And then this number you divide by the area that you're trying to cover. And then I would buy at least an extra 15 blocks, 10 to 15. Just in case you want to, like, maybe you're making your patio and you're like, I want to make it a little bit bigger. Or actually where the barbecue is, I would like that to be paved as well. It just fits, right? Because once they get run out, they don't have them anymore. Oftentimes the style is done, right? So they could do the cost. They could ask for it. They didn't. So that's a major problem that has a lot of moving parts that you were just given here. Okay. I want you to work through 35 and 37, pages 35 and 37. Okay? And page 37. I will post them. I'll post the keys to them. Here's where I need to, before you start, I just want to like prep this for you, okay? You ready? You're not going to like this too much, right? But this one gives you a little bit of choice. This gives you a little bit of choice. So for example, I actually got rid of the choice. Never mind. Last summer I got rid of choices. So I'm telling you that you have to have 2 large fish, 3 medium fish, and 4 small fish, like in this aquarium that you're building. But the original provincial exam gave you the choice to have as many fish as you want, but you couldn't go over budget. So who said it yesterday? Just pick the cheapest, right? Pick the cheapest, pick the smallest. Like, don't go crazy, right? Just keep it simple. But anyways, read this. It's very good practice. Just so you know, 36 is completely blank. So you can do the work for this on page 36 as well. Okay, I did that on purpose. So start working, and I'll walk around and help you out. I want you to start thinking, right? What do I need to do here?